Welcome to the next of the series of talks about our WebAssembly journey, and I'll try to scratch underneath the surface where the interesting bits are regarding the technologies. So if you had asked me a year ago, running an application in a browser, is that a laughable idea, I would have said. I mean, the browser is there to show documents and you navigate with the back and forth buttons through your reading experience. And if you want to run anything, there's this silly JavaScript language. This is totally dynamic. Sorry? No, reality. Reality, it's hard. And yeah, I mean, JavaScript, that's a language you can't make that fast. Can't work. Forget it. People, this is like the x86 rule started to rule the world by accident and not by design. And this is how browsers suddenly started to be the gaming engine for the young kids, but nothing for me. If you ask me today, I would still say, this is insane. This can't work. This doesn't work. But I gained a tremendous amount of respect for those who say, fuck it, try anyway. Because, yeah, there is these problems of it not being your native desktop environment. And there is people out there who apparently try to give you the illusion that it is your desktop environment. And this, if you look underneath the top layers and go deeper and deeper, your respect for this work that is done out there is really growing by every layer that you step through. This is tremendous work. So thanks for everybody who worked on that. So where are we? There's the browser, there's the JavaScript, there's the WASM. Those who sticked in this room for longer than 10 minutes already know about most of this. And you also know that we want to put the LibreOffice inside of there and naturally into the WASM part. How do we do that? With the Emscripten, as we already know. And the one part of Emscripten is to actually compile your bits to this WASM runtime language, kind of assembly stuff. And another interesting part of Emscripten is that a binary by itself can't do much, so it can't even print anything or read anything or get any interaction with the outside world. So it needs some kind of standard C library at the very least. So another big part of this Emscripten thing is not only compiling code, but also giving you the illusion or a simulation or some kind of illusion in a way that you're running in something that you already know and that your program already expects to find, which in this case is the C library POSIX variety. So coming from the Unix world, thank God they didn't decide to base it on the Windows API, for example. So that's a good plus there. And this is a real big blob of JavaScript code that runs in the background. And if all things go well, you never see anything of that. It all works in the background. But if things don't work as well as you would hope, then of course you do have to look into that. And as always, we're a very big application. We use all kinds of crazy stuff. We have gathered all kinds of crazy hacks and workarounds and whatnots over the 20, 30 years, 40 years that we are running by now, 30 years plus. So yeah, what can possibly happen there if you bump this crazy big thing of LibreOffice into this small browser world and give it a splash? Lots of things can happen. First thing, for anything that is of interest is having multiple threads. So that's a need by now. As Torsten said, they tried to start out with no threads, and that very quickly runs into issues because nowadays, even something that looks sequential on the surface underneath does use threads naturally, and we would have a hard time getting LibreOffice code base into a fully featured no threading thing. That's beyond possible, I guess, and so we need threads. The browser doesn't have threads. From Moritz's talk, we learned it has this web worker thing, which is just another instance of JavaScript with another instance of WASM in that, and the one browser tab pretends to have multiple threads just by running multiple instances of this JavaScript plus included code. And they can't really see each other, so they don't have this shared memory by default. We have this shared WASM blob, and we have some sort of communication channels between these instances, but that's also not an easy thing to do, as we'll see. So it comes at a price that they can even talk to each other. That's not a given. So if you look into one of these instances for each individual thread, there's some nice things as well, and some wonderful things that are just working. Like you have, each one is a single-threaded thing in the end, so it has one call stack, and you can easily move between JavaScript and WASM code there. So you can easily go from the JavaScript world to our C++ world, compile to WASM, and back again. That's no issue. That's great. And you can even throw exceptions through all these frames, and they also work, which is also great. And there's two kinds of exceptions, which is a bit of a problem. What is not so nice is that this whole call stack, the browser engine doesn't want you to do that. It wants you to only always, on each of these JavaScript per thread instances, it always wants you to have, so at the bottom there is from the browser this event loop. And then when an event comes in, when the user clicks something, or when the JavaScript code uses some async mechanism to wait for something, then whenever an event happens, then your code gets executed, this little piece of code for this event. And the browser doesn't want you to do lots of time-consuming stuff in your event handling, because then other events queue up and can't do anything, so the browser freezes. And that's not exactly how the LibreOffice code is designed. Because the LibreOffice code has this. So at the bottom there's the browser event loop, as I said. Then there's our main function. This is where LibreOffice starts. We then have this abstraction of not using main directly, but some VCL application main, and then we call from VCL into Qt, and then Qt has its own event loop, where a Qt application gets some stimulus, the user types anything or clicks anything or whatever, and then the Qt event loop handles these events. And then our code on top of the Qt event loop, then when you type a letter, then in Writer, the letter appears in your text document. So we have another event loop there. And if we want to run that, we would need input from the browser event loop. But the browser event loop is blocked. It's blocked by all the code at the top of that. So no events would come up there. We would see the LibreOffice, but it wouldn't respond to any input. It would be a dead office. Don't want that. So what's the trick there? Yeah, just before we enter this event loop, we just nuke all the code underneath it and go back to the browser and tell the browser if there's a new event coming, then please call this event loop, which is no longer on the stack, but it'll call it again, and it'll then reappear on the stack. There were some stack frames in between here. They're gone now. We killed them. If there were local variables in there, they're gone. If we created anything on the heap while we were in this part, that would still be there. Because what happens here is, at this point, we throw a JavaScript exception that can walk through the stack down. As I said, exceptions can fly wonderfully. And these JavaScript exceptions are such that if there is any C++ frames, WASM frames in between, which would have destructors, then they are not called. So anything that Qt puts here on the heap with the class instances that would have destructors, they don't get called because we throw a JavaScript exception. And there's two kinds of mapping exceptions from JavaScript to WASM. And one is they remain JavaScript exceptions and they don't do destructors. And the other is to use the newfangled WASM exceptions, which is a relatively new specification. And we need that for our own code. So Qt is compiled with the old exception semantics. Nothing gets destroyed. Our part of this code here is implemented or is compiled with the new semantics, where C++ destructors do get called. So but we only had one variable, one class instance in this part of the stack that we need to preserve. And initially I wondered why that gets destructed until I had this aha moment, and that is because we throw this exception there and use the new exception semantics for our code. And then I just hacked it around. So if we are compiling for mscripten, then we're not putting that, then we're not instantiating that variable normally. So they would get destroyed when we walk down the heap again, but to just create it on the heap with new and then leak it, because we need it until the end of the application anyway. And problem was solved. But it took me a while to figure that out, because what you see from the outside is that you assume that the code reached the Qt event loop here and continues from there, but in reality all this code is gone. Bye-bye, never to be seen again. Now, this code in our event handler then wants to do something. So we are calling, a key gets pressed, and then the grammar checker shall kick in. The grammar checker runs in the background. The grammar checker wants to have its own thread to not block the main thread while it does its complicated grammar checking. So our code calls this our abstraction of how to create a new thread. What can go wrong? We are in the main thread, browser main thread. We run there. We want to create this second thread. To do that, we need this cloudy, fluffy blob of JavaScript code that the mscripten library brings along. So what that wants to do is, we call also create thread. That calls a pre-thread create in the background, because we have this POSIX abstraction around the POSIX layer. So WASM doesn't, or mscripten doesn't have real POSIX, but it sees, there's somebody trying to call pthread create. I then give them my simulation, my illusion of doing a pthread create. For that, it spawns one of these other web workers. But then the one JavaScript instance wants to talk to the other new JavaScript instance, the new web worker that was just created, to tell it what to do. It needs to run something. And so these two need to communicate. And for this communication to work between these two instances, then this one has to be down at the bottom of its, to the browser event loop again. But we are in our code up there somewhere. The browser event loop is again blocked. So this can't talk to that to tell it what to actually do. So we are blocked again. So the trick there is one more thread. We have the browser main thread. This one just calls the browser event loop and then does nothing. And then we have a second thread which runs the the LibreOffice code. And this has also the browser event thread. On top of that, this faked Qt event thread, as I said. From there, we go to this also create thread thing in this part here. That one then needs a new thread. It doesn't call into this fluffy block, but it dives down the stack because the mscripten code can do that to call over here without needing this unblocking stuff. It tells this one to do all the housekeeping to create the new web worker and to communicate with that. And this one isn't blocked, so it can call this one. So, yeah, because this one is the main browser thread is the one that does the most of the work for the mscripten POSIX emulation or simulation. And so with that set up, we now can finally create the third thread while we are blocked in this thread, waiting for this thread to be created. But to make all this work, to make the actual application run in a second thread, there is a switch for the mscripten. So when you compile the LibreOffice with mscripten, then you pass this proxy to pthread thing, and that does this two-step for you in the background. But then in here, we have this Qt. And we don't use Qt because we think it's cute, but because it was the only backend, VCL backend that was available. But Qt itself is not happy about this setup. So Qt code expects to run here. So the Qt code expects to be able to access the browser window and all the stuff which is only available here in this JavaScript code. When it tries to do that here, it runs into undefined, and then boom. So we had to, we already had some hacks on top of, or some fixes on top of the original Qt code, and now we have even more, where I try to get it to live in this new environment where it is running here and doesn't have access to the actual browser window. And it kinds of works. Probably missed a few cases. So when we first tried it out on Mac, it didn't work at all because I had forgotten one case that was Mac specific. And maybe there's lurking more. But that's the story of how we got at least a third, or from our idea, a second thread, so the background grammar checking thread working. And that was quite some time I spent there on digging through these layers and trying to understand and then fix pieces into place so that they all work nicely again. On the plus side, there's other parts of POSIX that are much more pleasant. They just work out of the box, like everything that is the basic synchronization mechanisms. That just works wonderful, so you don't need to peek into the JavaScript code to find out how they implemented that. I have no idea yet. Maybe we need to peek into that as well at some point, but for now that just works. File system, for example, as Moritz already showcased, there's this virtual file system. It's not your real file system, but at least that virtual file system gives you a place to put your temp files, for example. So whatever you get into your browser, you can work with that. Another thing would be sockets for inter-process communication or calling out into the world. There is kind of a bit of trying to make that work. It also runs into this same origin problems, of course, because for security reasons, the browser doesn't expect your browser tab, your application in the tab to reach out to arbitrary places. So that's an issue. So there's some additional process. You can run a native additional process on the side that would get all your sockets system calls proxy to there by this mscripten illusion part and then proxied back. But that's very experimental and might be useful for some use cases, but not for the general one. Another thing that is completely shaky still is the dynamic libraries thing that Thorsten mentioned, so we still don't use any of that. We still have this one big blob application, not split up into multiple libraries, because that's also something that we'll have to wait for, don't know, 5, 6, 7 more mscripten versions. They are always quick they are releasing on a very regular basis, and sometimes they break things, then we have a hard time that they introduced a new bug that hits us, and we have to find a workaround for that. But most of the time it's just that, as Thorsten already said, time is on our side, and other people doing their great work are on our side and fixing in our back things that we can then rely on and use, which is wonderful. Which gives us a time to spend at the lake again. Any questions?
Is it possible to switch the browser threads immediately to the user threads? That will be maybe a solution.
What do you mean with switch?
Connect. Also the browser thread should immediately call a part of the LibreOffice stuff. Because the two threads are terrible.
Yeah, so the threads themselves can't talk to each other.
I was confused. I mean the event queues.
Okay, no. So whether the event queue. So the question is whether these event queues could in any way talk to each other more easily. Like over here. And no, that's not possible, unfortunately. So whenever you want to, so when for example, this one wants to talk to that one again, then these message queues are, or this communication channels are designed in a way that they need this upper event loop, browser event loop, to be unblocked, to be nothing running there, because now they are kind of new events that are coming in. So that if this is still working in some of our code, then they can't, for the time being, they can't communicate, and that's the heart of the issue there, unfortunately. Yeah. Any other questions? Otherwise, thanks for coming. See you around.